So inequalities in systems, there'll be 8 to 9 questions. And we tried to break it up the best we could. So today we're going to talk about the graphing part. And then tomorrow we're going to talk about writing and solving. So tomorrow is going to be a considerably more difficult day than today. But we are going to learn a couple of strategies today that might take a little time. Okay? So let's start with linear inequalities. And again, it's hard to say how many questions because they don't ask every year. That's why it's so weird. Like some of them they'll ask every other year. Sometimes they've asked 2 out of the 3 years or 2 out of the 4 or 3 out of the 4 years. So it's not consistent because again, a lot of these questions, especially the ones, so they have, and this is neither here nor there, they have what's called readiness skills and then they have what's called supporting skills. The readiness skills, every one of the readiness skills is asked 2 to 3 questions a year, and there's about like maybe 13 or 14 of them. The stuff that's in your homework. 5% of the questions are going to be stuff like that's in these books, okay? But the other ones, they only ask 35% of them, and there's more supporting ones. And so, like, it's kind of random which ones they get. They don't get the same ones every year. So, we're going to start with graphing. Okay, now this part right here, this is not our skill, okay? This skill right here with the inequality signs, the reason we included it is because you need this for writing domain and range. We need this for writing domain and range, okay? But this skill is like, I think, maybe a 7th grade skill, maybe a 6th grade skill, graphing one variable inequality. So this is not our skill, but we needed this part for domain and range. This is our skill, okay? Our skill is identifying the correctly graphed inequality and identifying values that are in the solution set, okay? So our stuff is 2 variable inequalities. All right, so when we talk about linear inequalities, let me see if I can find this because I want to see what I did last period because it was decent. Oh, man. Okay, whatever. All right, so first of all, these signs, the shade above and shade below part, this shading stuff, it's only valid if the equation is in y equals mx plus b form. Okay? So the shading, we can only trust the shading part if we're looking at something in slope-intercept form. Okay? Because the shading, we could have a flipped sign. I'm going to show you a different strategy than shading just as an option. Okay? And it's actually a good option, so really consider it. Now, remember, the thing that we can always do to eliminate those, we can always eliminate the boundary line. Okay? So if it's greater than or less than, it's going to be dashed. And if it's greater than or equal to or less than or equal to, it's going to be solid. Okay? So, we always, when we see an inequality and they're asking us to match it, or they see a graph and they're asking us to see what inequality goes with it, we are always going to start by eliminating based on whether it's dashed or solid. You can usually eliminate 2 answers just like that. Okay? Now, I'm going to do this first one for you. I want you to watch, and then I'm going to give you some time to practice a couple of others. Now, this one right here, okay? I'm just going to tell you right now. This was we've seen questions like this on 3 separate occasions. So there's a pretty fair chance you're going to see one. You don't even have to shade to get this answer right. All you got to do is plot the points. Let me show you. I have a point at 0, 5, so I'm going to plot that point and I'm going to label it A. Okay? The point at 5, 0, I'm going to plot that point, label it B. Plot at negative 2, 5, negative 2, positive 5, label it C. Negative 5, 2, label it D. What's the answer? It's B. It's the only one that's not like the others. Okay? I don't even have to shade to know what the answer is because I can tell. Because remember, when we look at inequalities, there are 3 places that we could have valid solutions. I could have solutions above the line, I could have solutions on the line, or I could have solutions below the line, right? I can have on and above or on and below, but I can't have above and below at the same time, right? Because then what would be the point? All right. So if I have 3 here and 1 there, this has got to be the one I'm looking for because it's the one that's not like the others. Now let me show you this. I want to show you this example just in case. Take a look at this one. Let's do like this. Why not? And I have a point here. And I have a point here. I have a point here. And I have a point there. What's the answer?
D.
What's the answer?
D.
D. Because there's 2 below the line, right? And 1 above the line. It can't be either one of these 2 because I can't pick 2 answers, right? This one's above the line and this one's on the line. But I'm allowed to have below and on together. I'm not allowed to have, you see what I'm saying? It has to be the one that is completely by itself. Do you have a question back there? Okay, I was just checking. Okay? And what you'll find is if you see a problem like this, it'll have a solid line. Okay? So, I want you guys to try this one right here, number 7. Try number 7. I'm going to give you all a minute to try it. When you're ready, but not until you're ready, take a look and see if you agree with what I got here.
I agree.
Right? I mean, I have 3 above the line and 1 on the line. It's got to be the one. Okay? Now I want you guys to try number 37. It's the same thing, but what's different about this one? Okay, so let's talk about this one. There's no line, right? So this time I got to draw the line, which, now I got to think a little bit. Okay? Dang, we've been doing so good with not having to think very much. Fourth period looked so irritated with me. They were like, I was like they're not buying anything I'm selling. And I'm like, do y'all feel like we should be doing more like algebra? And they're kind of like, yeah. And I'm like, maybe we should, but this is the STAR test. We're just trying to get the best score we can. Okay? And if we can get the answer without, why not? Okay? So, let's talk about this. We have y equals mx plus b. All right? And this is in slope-intercept form, but obviously it's an inequality. And again, I don't know if this is what it's supposed to stand for. I'm pretty sure it's not, but here's how I think about it. M stands for move. B stands for begin. Okay? So, on this problem, I'm going to begin at 0, 4. And I'm going to move, I'm going to rise 1, run 3. Okay? So I start at 0, 4. Rise 1, run 3. Rise 1, run 3. And I just keep doing that. And, I can connect the points if I want to. I don't have to, but I can. It's no big deal. Okay, I can connect the points if I want to. Okay. Okay. Now that I've done this, now I can plot these. Okay. So -6, 1 is A. -1, 6 is B. 6, -1. See, I already know the answer. 1, -6. There it is, up there all by itself. Okay? Yep, did you do the work yourself? Yes. No. Yeah, I know it's below the line. But even if A was on the line, B is still the only one off by itself. B is still the answer.
So, according on the line,
No, well, in this case, no, that would not be part of the solution set because the line is solid. It's probably been plotted wrong. Okay? But it's the one that's not with all the rest of them. Okay, let's try a different one now. Now that we've done that, let's look at a different type of problem. Okay? And it looks like this. Okay? It says, which graph best represents the solution set of y greater than 3x minus 4? Okay. This one's in slope-intercept form. But still, the first thing I'm going to do is I'm going to identify what kind of boundary line I'm going to have. What should I have, dashed or solid? This is dashed. So I can get rid of A and B. Exactly. Now, at this point, I have to know which way to shade. So, let's pretend that you don't know that when it's greater than, I draw an arrow pointing up. And what I'm pointing to should be the shaded area. So let's pretend that you completely 100% freak out. And you're like, I don't know. Okay. Here's what you can do. And this strategy works for everything, but it really works for problems like this one, or things that are in standard form. You're going to pick a test point. And I'm going to tell you exactly which test point to pick. You're going to pick the origin. 0, 0. And here's why. If I plug in a 0 for x and a 0 for y, I'm going to get a statement, right? And it's easy to plug in, because if I plug in a 0 for y, it turns into 0. If I plug in a 0 for x, 3 times 0 is 0, and I'm left with -4. And I have a statement right here. If the statement is true, then the origin is in, hold on, let me zoom in a little bit, then the origin is in the shaded area. If it's false, the origin is in the unshaded area. Okay? So, I'm going to look at this statement and decide, is it true or false? Is 0 greater than -4?
Yeah.
Yes. So this is true. That means the origin has to be in the shaded area. D on C it's not, so that one's out. Okay? So, I want you to try that here. Try that process here. You start by eliminating based on the boundary line, and then you're going to look at the origin. You're going to plug it in and. All right. So let's take a look and see if you got the same thing I did. Okay. It's a solid line, so I eliminated these two. When I plugged in 0, I got 0 less than or equal to -54, which is false. So that means 0, 0 has to be outside of the shaded area. This one's inside, so it's wrong. A is all that's left. Okay? So again, even if now, I want to point something out to you. And this really, this had fourth period shook. Okay? They were they almost couldn't get past it. This sign says less than or equal to, but the answer's shaded above. They were like, but why? And I'm like, because when you solve to get it in slope-intercept form, you end up with a sign flip. Remember the sign flip? You end up with a sign flip. But guess what I don't have to worry about now? The sign flip. I don't care about that. I'm just plugging in a point. Okay? I want y'all to pause. I'm going to pause for a minute. I want y'all to do this one and this one. And I'm going to tell you right now, you might get stuck on this one up here. But I want you to get as far as you can. So you're going to do 47 and 3. Okay. Did y'all get the same thing I did here? Yeah. Okay, awesome. We won't talk about that other thing. Okay. Now, for this one. Okay, so I was able to eliminate. I should have a solid line, right? So I was able to eliminate these two. When I plugged in 0, 0, I got 0 less than or equal to 0. And that's a true statement. What? Boo. I'm sorry. Boo. I wrote boo on top of them. Boo. Okay, I don't know why I did that, y'all. I'm sorry, Internet. That happened. Okay, but 0 less than or equal to 0 is true. Okay, so that didn't help me. Right? That didn't help me because the origin is part of the solution set of both of these. So, if that point doesn't work, you're gonna try another point. I'm going to show you a list of points you're going to try, and then I want you to tell me why I picked them. First, you're going to try this one. Then you're going to try this one. Then you're going to try this one. Then you're going to try this one. Tell me why I picked those points. Tell me a reason why I would pick those specific points. I mean, yeah, they're on the parent function, but why these points? Because I can't mess up plugging these in for x and y. Because they've got the same x and y value, I'm not going to screw up and put the x in the y spot or the y in the x spot. It doesn't matter. They're the same number. Okay? So let's say, is 1, 1 part of my solution? It's not in this one, and it's in this one, right? So if I plug in a 1, I get 1 less than or equal to negative 4. Is that true? Is 1 less than or equal to negative 4? No, that's false. So 1, 1 should not be in the solution set. Do you see what I'm saying? So, but the reason why so we start with 0, 0 because 0, 0 is the easiest to plug in. But then we do points that have the same x and y because number one, they're easy to plot, but also they're hard to mess up. It's hard to mess up substituting. All right? Okay. That's all. Okay, well, there's actually one more question. Let's talk about this one. Okay, this one we kind of we've skipped over this question a couple of times, so we'll talk it out. This one is actually a really good example of where you can pick your own test points that make sense for the situation, but you got to read it carefully. So it says a college student has 2 different jobs. Her combined work schedules consist of no more than 48 hours in 1 week. So she has to work 48 hours is the max. That's the max she can work. Okay, which graph best represents the solution set for all possible combinations of hours she might have worked at her first and second job? Okay, so what I'm going to do is I'm going to try to make up some combinations of hours that could work, that could be less than 48 hours, okay? So, I mean, I'm looking at this. This one says 6 hours. Could she work 6 hours at the first job and 6 hours at the second job, and would that be less than 48 hours? Yeah, okay. So I'm going to try that same point on all 4 of these. And take a look at that. I eliminated B. Okay? So what if she worked 6 hours at the first job and 30 hours at the second one? Would that work? Because that would be 36 hours, and that's less than 48 hours. Okay, well, let's try that on this one. 36, I'm sorry. Here, doesn't work. So C's out. 6 and 30 works on this one. Okay, what if she worked 30 hours at the first job and 6 at the second one? Okay. There it is. And again, I'm just putting them in here because why not? Oh, look at that. Doesn't work on D. A is the only one that works. And again, all I did was think about the situation and pick some test points that should have worked. And then I see where they work. Okay? What do we think? Okay, so that's the first topic. The second topic is systems of inequalities. And look, it's never been tested, but there's first time for everything, and I'm not trying to, I want to make sure that we're ready for it. Okay, so with a system of inequalities, this is a highlighter question, okay? And what I do, honestly, I highlight the double shaded area. So actually, there's 2 ways they might do it. They might double shade, or they might do what's called cross-hatching. And those of you who are in art know what cross-hatching is? So cross-hatching is where you trace one way, you do one way, and then the other one a different way, and where they make X's, that's it. That's where the cross-hatched area is the place where they cross. Okay, so you might see cross-hatching also. But what you're going to do is, so in this case, the area right here is the solution set. On this one, the area where they overlap is the solution set. And this picture said it was in like orange and pink and yellow, but you know what? We have black and white. So we're going to color it in. And then what they'll give you is it'll be a problem like these, where they ask you what points are in the solution set. Okay? And then you have to find which point's not in that area. Okay? That's what they usually ask. And that's the skill, focus up, that's the skill that you're expected to know. Okay? Again, they've never tested it, but I want to make sure that I reviewed you on it. Okay? Any questions about that? Okay, I'm going to stop this recording, and then we're going to do one as a separate topic because it is kind of separate. Stop.